Okay, so 3.2, it's going to be all the same kind of stuff. So now we're just going to do a bunch of questions that are kind of based on the same thing, right? So Bailey holds all the spades from a standard deck of cards. He asks Morgan to pick any card. It says determine the odds in favor of, Morgan choosing a face card. So I'm going to look over here. How many face cards do we have? Three, right? 1, 2, 3. I always forget that kids don't play cards much anymore. So we got 3. So 3 is going to be my in favor part. What's my unfavorable? Like everything else, right? The complement. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 to 10. Okay. Determine the odds against Morgan drawing a face card. 10 to 3, right? You just do the opposite there. So 10 to 3. Determine the odds against Morgan drawing a card 5 or less. All right, so if you get a little bit confused about, okay, how to start with that, I would just do the odds for a card 5 or less, and then switch them. Just so you don't confuse yourself here. So let's figure out all the cards 5 or less. So that's going to include ace in our deck. So that's going to be 1, 2, 3, 4, 5. So it's going to be 5, right? So there would be 5, 2, and then what's the other side of this? How many cards do we have in total? 13, right? Yeah. Oh no, sorry. 13. So 5 to 5 to 8. They have to add up to 13. Okay, so then it says the odds against, right? So then what are we going to do? Just flip it around. Don't forget to flip it around. 8 to 5. All right. Probability of an expectant mother selected at random of being pregnant with twins is 1 out of 32. What are the odds of a mother being pregnant with twins? Okay, so what was this number up here? Was that odds or probability? That was probability, right? That top number is favorable. What's that bottom number? That's our total. Okay, so the odds here are still going to be 1 to something, but what's my unfavorable going to be? 31. Yeah, see that? Because that has to add up to 32. So it's going to be 1 to 31 for odds. Okay, what are the odds against an expected mother having twins? 31 to 1. All right, suppose the probability of an event happening is 2 over 5. All right, so probability, that 2 is your favorable, that 5 is your total. What's the probability of the event not happening? All right, so probability, so then we're not odds this time. Probability, do we know what the bottom number is going to be? Because probability is going to be total on the bottom, right? Okay, this is really going to be like unfavorable up here because it's the event of it not happening. But our total is going to be the same either way, right? It's still going to be 5. That's how many we have in total. Unfavorable though, 3, right? Because there was 2 favorable, unfavorable has to be what's left there. So it's going to be 3 over 5. Okay, what are the odds of the event happening? Of the event actually happening, right? So 2 was our favorable. So it's going to be 2 to 3. Favorable to unfavorable. What are the odds of the event not happening? 3 to 2. It's not too bad, eh? All right, this question's kind of worded a little funny, but we'll kind of make it into our own here. It says you've entered a contest 250 times. And the computer says your odds of winning are 1 in 9. I should have said 1 to 9 if it was odds. It would have been 1 to 9. 1 in 9 would be probability, so that should have been 1 to 9. How many entries are in the contest? So really what they're saying is like, if I played this many times, how many times should I win? It's worded really funny, but that's how we're gonna interpret this. So if my odds are 1 in 9, then what would my probability be here? Or 1, 2, 9, I should. 1 out of, how many would I have in total? If I've got 1 chance of winning and 9 chances of not winning, how many do I have in total? 10. 10. Right, so this is what I told you. It's like it seems really straightforward, but it always gets people. So 1 out of 10 would be my probability of winning here, right? So what we're going to do is we're going to set up a ratio. So this is my probability. I played 250 times. My X value here is going to be how many times I should win out of that, right? Because if I play 10 times, I should win once. If I play 250 times, how many times should I win, right? We're just setting up a ratio. Do you guys know how to solve for X here? Yeah, we can do fish. We're like do cross multiplication, but I think you guys are above this or above that. Yeah, so fish, it's just this, the bottom one times that one divided by that one gives you this one, right? We can do that, but you guys know algebra, right? If we've got it written like this, if I want to get X on its own, where does this 250 go? It goes up there, right? We multiply both sides by 250. So in the end, this will just turn into X is equal to 250 divided by 10. It's the same thing. That's where cross multiplication comes from, right? It's just doing algebra. It's just like a cheat for doing algebra. Right, so 250 divided by 10 is 25. So you should win 25 times if you played 250. If you played 250 times, you should win 25 times. Okay. So what's your probability of winning? So that's how many times you should win there. What's your probability of winning? We kind of already gave it, or we already figured that one out, right? Probability, we said, was 1 out of 10. So what's my probability of winning as a decimal? 0.1. What is it as a percentage? 10%, right? Okay, suppose that the odds in favor of an event are 5 to 3, right? So 5 is my favorable, 3 is my unfavorable. Is the probability that the event will happen greater or less than 50%? So probability, I need to write this as a probability, right? So I need to have probability is favorable over total. All right, so 5 over 8, right? 8 is my total there. Is that bigger or less than 50%? Come on. Yes, bigger than 50%, right? 4 out of 8 would be 50%. So this will be bigger than 50%. All right, a hockey game is tied after overtime and is going into a shootout. The coach wants to decide who to use in the shootout. Show that Ellen is the better shootout scorer using both odds and probabilities. Why might the coach choose Brittany over Ellen? All right, so Ellen has attempted 13 times. She scored 8 times. Brittany's taken 17 shots and scored 10 times. So we want to figure out probability. We'll do first. Which one had a better probability? Well, this is favorable, right? Getting a goal is favorable here. So for Ellen, her probability is going to be 8 over Over what? 21? No. 13, right? The attempts is the total. That's how many shots she's taken in total, right? So that's going to be the total. So 8 over 13. Okay, and I would write this as a decimal because decimals are a bit easier to compare than fractions. So I'd write this as, so 8 divided by 13. This is going to be 0.62, which is 62%. So 62% chance of scoring, right? For odds, what would her odds be? So favorable is 8. What's her unfavorable? Yeah, 5. So 8 to 5. All right, so now let's compare that to Brittany. So the probability for Brittany is going to be 10 over 17 was her total, which is 59%, 0.59 or 59%. So we can see, right? This one is better than this one. Her odds are going to be 10 to 7. Okay. Why might the coach choose Brittany over Ellen? She has worse chance of scoring, I guess. It's kind of a silly question. I don't know. The what I took from this is that she might be more likely to shoot. Right? She might actually shoot. Yeah, it's kind of a dumb question. Yeah. All right. You know what? Let's see. All right, so you were at a carnival and had a choice of playing BIM. So the odds against winning are 5 to 2. And Zap, the odds against winning are 7 to 3. Which game has the better odds? So what I'm going to do right off the bat here, because they told me odds against winning for both of them. I'm going to do it the other way around. I'm just going to say, okay, BIM has odds of winning of 2 to 5. Okay, just switching those around. And Zap has odds of winning of 3 to 7. All right, now you might say, okay, now which of those is better, right? It gets a little bit confusing on knowing which one's better. One that's a little bit less ambiguous is probability, right? If you can like turn these both into probabilities, that's going to tell you which one's better, right? They're both a percentage. That's just like easy to figure out from there, right? So let's write this as a probability. So this is going to be, so BIM is going to be 2 over 7 as a probability. It's a probability. So then I'm going to write that as a decimal too to make it even easier. So 2 divided by 7. So we get 0.29 or 29%. Zap is going to be 3 over 10 or 30%, 0.3 or 30%. Okay, so now it's a lot easier to see, right? They were very close. This would be hard to do if we just had them written as odds, right? But now that we've actually figured it out as a decimal, it's clear that Zap had the better odds. Okay, so last one. Let's let you guys try. Should I leave the video on the whole time?